Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss a topic of linear differential equation of second order with constant coefficient. So here I am discussing about a standard differential equation that is known as a linear differential equation of second order with constant coefficient. So how we can find complementary function and particular integral of given standard differential equation with constant coefficient. So here we discuss in detail about the complementary function and particular integral. So here we give a derivation of a formula. If in any question this differential equation occurs, then we apply direct formula. In question, we are not proving this result. We are apply direct result. But here I am showing completely proof of PI in this lecture. Here we will discuss of linear differential equation of second order with constant coefficient in standard form. What here Q equal to sin AX or cos AX. Q is the function of X, but function of X is only sin AX or cos AX. No other function, tan AX, cot AX, cosec AX, sec AX, these four functions are not allowed here. Trigonometrical function. Out of trigonometrical function, sin AX, cos AX, tan AX, cot AX, sec AX, and cosec AX. Only these two functions are allowed here. These functions are not allowed. We cannot find PI of these four functions here. We can find PI, but their method, we apply different method. That we will discuss next lecture. How we can find a particular integral of tan AX, cot AX, sec AX, and cosec AX. But in this lecture, we are discussing only if Q is sin AX and Q is cos AX. So here I am writing standard differential equation of second order with constant coefficient. So here standard differential equation of second order with constant coefficient is d2y dx2 plus a square y equal to q. This is standard function here. This is equation 1. Where is a constant, is number here. In this question, this is linear differential equation of second order with constant coefficient. So here is number here. This is equation 1. What here Q equal to sin AX or cos AX. Q is sin AX or cos AX. So I am discussing in this lecture how we can find particular integral of this given differential equation and complementary function. Then how we can find complete solution. So we are giving here derivation of this differential equation. Problem 1 in case 5. We will discuss of only two standard differential equations. Here solve d2y over dx2 plus a square y is equal to sin ax. This is differential equation 1. And other is d2y over dx2 plus a square y equal to cos ax. This is equation 2. So how we can find complete solution of these two differential equations? These two differential equations are known as a linear differential equation with constant coefficient of second order. What here we are seeing in this differential equation, there is second derivative d2y over dx2 and plus y only, no derivative. So where is first derivative here? If we comparing this in general equation, then we find P1 is 0. So after comparing this equation d2y over dx2 and plus P1 dy dx and plus P2y is equal to Q. But our equation is d2y over dx2 and plus P plus a square y is equal to Q. So here P1 is 0 here. Here P1 is 0 and P2 is a square and Q is sin ax. Here is sin ax here. Sin ax. So derivation or solution. How we can solve these two differential equations. So equation is d2y over dx2 plus a square y equal to Q. This is standard equation. What Q is here, we are taking only sin ax and cos ax. So d2y over dx2 plus a square y equal to sin ax. This is general equation 1. This is known as a general equation. d2y over dx2 plus a square y equal to Q. This equation 1 known as a general equation. Q is some function there, that is question. So in our question is d2y over dx2 plus a square y equal to sin ax. This equation 2. This question given in our question paper. Then how we can find complete solution of equation 2? So here both equation have function is changed sin ax and cos ax, but equation is same. So we solve simultaneously both equations. We find solution simultaneously of both equations. So here equation 2, this equation 2 can be written as, so here d2 by dx2, this is the second derivative, this is represented by d square and plus a square, y is common, equal to sin ax. This equation can be written as, this is derivative form d form differential equation. This differential equation also known as a constant coefficient. This equation 3. Next, d2y over dx2 plus a square y equal to cos ax. This is equation 4. Here, d2 over dx2. This is d square. d2 over dx2 and y equal to d square y. d over dx, this is d. And d over dx of y, this is dy. These values putting in our question, then this equation 4 convert into this result. So here this equation is writing in d form. In case 5, here we will solve following both equations simultaneously. We find the solution of both equations simultaneous with the method of y is equal to CF plus PI. Y is equal to complementary function plus particular integral. So here I am writing equation 3 and 5 in D form. 3 and 5 I am writing in D form, derivative form. So here d square plus a square y equal to sin ax, equation 3. D square plus a square into y equal to cos ax, equation 5. So now we want to solve the equation 3 and 5. We want to solve complete complete solution of 3 and 5. So how we can find solution, we discuss here one by one. In equation 3 and 5, in equation 3 and equation 5, we have q equal to sin ax or cos ax. Either there is sin ax or cos ax. In one equation is sin ax and in other equation is cos ax. What right hand side part is same in both equation 3 and 5. We are seeing here in 3 and 5. Left hand side value is same in differential equation. This is LHS. Left hand side is same in both results, but right hand side function is changed. So here in equation 3 and equation 5, we have q equal to sin ax or cos ax. Then there are two parts of the solution. First part of solution is CF and second part of solution is PI. First part CF, complementary function, and second part of solution is PI, particular integral. So here first we will discuss of complementary function. CF. CF means complementary function. Complementary function. How we can find complementary function? To find CF, putting q equal to sin ax or cos ax, this must be equal to 0 when in our linear differential equation with constant coefficient. When right hand side is 0, means q must be 0, then we can find CF. Otherwise, if we are not putting q equal to 0, then we can't find CF. So here we are taking q equal to 0 in our question first. Then we can find complementary function. So equation 3 and 5 becomes 6 and 7 after putting q 0. Putting q equal to 0 in 3 and 5, then we have from equation 3 and 5 this 6 and 7 equations. Only we are putting here q 0 in both equation. Right hand side must be equal to 0, so we are taking here q 0 so that we can find the complementary function of given differential equation 1 and 2. In equation 6 and 7, we see that left hand side of both equations are same. RHS is 0. In both equation, RHS is 0. So we have same CF of 6. Left hand side, not right hand side, is left hand side. Left hand side is same. Left hand side is same in both 6 and 7. 6 and 7 equation. This 6 left hand side, this is LHS, left hand side. This LHS, both are same, 6 and 7. So left hand side is same. Q equal this 0, left hand side is 0. So we have same CF of 6 and 7, same CF. So now putting D equal to 0 to find CF, putting D equal to 0 and removing Y from 6 and 7. In 6 and 7, putting D equal to M, not 0. D equal to M. D equal to putting M. Here putting D equal to M. And Y removing Y from 6 and 7. Because Y is a function of X. Then we get here M square plus A square equal to 0. This is equation 8 number. M square plus A square equal to 0, equation 8. This is known as a auxiliary form of equation 1 and 2. Both have same auxiliary form because left hand side is same. Here equation 8 is an auxiliary form of 6 and 7 because left hand side of both equation are same, because left hand side of both equations are same. So here we have same auxiliary form of both equations 6 and 7. So now solving equations 8. How we can solve equation 8 here? So here m square plus a square equal to 0. M square plus a square equal to 0 here. Now m square equal to minus a square. M square equal to minus 1 into a square. Minus 1 is I square. Minus 1 is I square. So m square equal to I square and a square. M square equal to IA ka whole square. So m equal to plus minus IA. This is roots. So here I am taking m square plus a square equal to 0. M square equal to minus a square taking right hand side, plus convert in negative sign. Then minus 1, here is minus sign means minus 1. Minus 1 into a square. But we know that here I equal to under root minus 1. I is imaginary number. I is under root minus 1. And I square equal to minus 1 here. I is under root minus 1 and I square is minus 1. So this value putting here, m square equal to I square a square. After squaring on both sides, be here m square minus I square a square equal to 0. So m square minus I a ka whole square equal to 0. This is m ka square. So I am apply here a square minus b square, a plus b and a minus b formula. So here m plus ai and into m minus ai equal to 0. So here if m plus ai equal to 0, it means m equal to minus ai. M minus ai equal to 0, then m equal to ai. So value of m is plus minus ai. 0 plus minus ai. This equation number 9. Here we find the value of m, because our auxiliary equation always be in m. So here after solving equation number 8, we find the value of m. These are the roots of m. So m equal to alpha plus minus I beta. This is the imaginary roots. Imaginary roots are given in the form of alpha plus minus I beta. So after comparing 9 and this, so alpha is 0 here and beta is 1 here. Coefficient of 1. Beta is a here. A. Beta is a here. AI. I beta is the AI. So beta is a. Roots of equation 8 are imaginary roots. We know that formula for CF of equation 3 and 5, if roots are imaginary, then we have CF. This is the formula for CF. If roots are imaginary, we have already proved this formula in last lectures. So here e to the power alpha x, c1 cos beta x plus c2 sin beta x. This is using the formula for finding CF of linear differential equation of second order with constant coefficient. If roots are imaginary of an auxiliary form, then we apply this formula. Direct we use this formula. We are not proving this. So here alpha is 0 and beta is a. So I am writing here ax. So here is answer is ax and plus ax. C1 cos ax plus C2 sin ax. There is mistake of a. Here is a. Ax. Printing mistake is there. So ax here. So this equation is 11. Now equation 11 is complete CF of equation 3 and 5. Equation 11, here I am writing here CF. CF equal to C1 cos ax plus C2 sin ax. This is CF. Because beta is a. Here alpha is 0 and beta is a. So these value putting here. Then we get complete solution. CF, complete CF. Equation 11 is complete complementary function of equation 3 and 5. Now, second part of the solution is PI. Second part of the solution is PI of given equation 1 and 2. 1 and 2 means 3 and 5. We are taking in D form. So Pi is equal to, we apply this formula, particular integral. Every step we are using this formula for finding particular integral. So Pi is equal to 1 upon Fd into Q. This is equation 12. So here putting value of Fd. Fd means function in D in our given question. So our equation is D square plus A square into Y is equal to sin AX. So this equation is writing Fdy equal to sin AX. So Fd is here D square plus A square. This is Fd. Our question is this. This question can be written in this form, in Fd form. Fd means some function in D. D is the derivative with respect to x. So here right hand side is function of x here. So Fd is D square plus A square. So putting the value of Fd and putting the value of Q. After putting value of Q and Fd, we get next. We have discussed here case 4. If Q is sin AX or cos AX in last lectures. Detail, we have discussed in detail. But here we are again telling about this. In this case, we will use same procedure if either Q equal to sin AX or cos AX. Same procedure. Because we find same derivative for sin and cos. So here d of sin AX equal to A cos AX. Differential of sin AX, A cos AX. We are finding some result here. So d square of sin AX equal to minus A square sin AX. Differential of cos AX means minus A sin AX. So here is minus A square sin AX. Third time differential of sin AX. 3 time differentiation of sin AX is here again differentiating this. So sin AX differential cos AX and AX into A. So minus A cube cos AX. Similarly, 4th time derivative of sin AX. Again differentiating this cos minus sin. So we write here A to the power 4 sin AX. Cos ka minus sin. So plus sin AX. A ki power 4 sin AX. And 5 time derivative is of sin AX. A to the power 5 cos AX. Similarly, we find next derivative. 6 time derivative of sin AX is minus A to the power 6 sin AX. And similarly, 7 time derivative of sin AX minus A to the power 7 cos AX. At last, D 8 time derivative. 8 time differentiating of function sin AX with respect to x. Then we get A to the power 8 sin AX. So after finding these all derivative, what is the final result? So here we are seeing there. Here we see all even derivatives of sin AX or cos AX or cos AX. Both functions you can find. So d square sin AX equal to minus A square sin AX. d4 sin AX equal to plus A4 sin AX. d6 sin AX equal to minus A to the power 6 sin AX. d to the power 8 sin AX equal to A to the power 8 sin AX. We are writing here 4 even derivatives. Now in all equation 13, 14, 15 and 16, cancel function on both sides. Cancellation function. This function cancel to this. 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 What will be happen? We find here d square equal to minus A square. D square equal to minus A square. First result. d4 equal to A to the power 4. So d4 is d square ka whole square equal to A4 is minus A square to whole square. So square is cancelled. We get this same result. Same as first result this. D square equal to minus A square. D to the power 6 equal to minus A to the power 6. D to the power 6 is D square का whole cube equal to minus A to the power 6 minus A square का whole cube. So cube is cancel here. We find same result this. And D to the power 8 equal to A to the power 8. D to the power 8 is D square का whole 4 equal to A to the power 8 minus A square to the power 4. So 4 power is cancel. We get D square equal to minus A square. So in all result, we get same result. We find here D square equal to minus A square finally. Ultimately here we have proved that D square equal to minus A square. We can put in any place of particular integral D square equal to minus A square in denominator of Pi, not numerator. Pi is equal to formula. Pi equal to 1 upon Ft into Q. This is 12 equation. Putting from equation 4, value of Fd and value of Q. What is value of Fd and value of Q? Putting in equation 12. Pi equal to 1 upon D square plus A square into cos Ax. What is Fd here? Here in our question, Fd equal to D square plus A square. And what is Q? Q is cos Ax. Both value I am putting here in this 12 equation. So here Pi equal to 1 upon D square plus A square cos Ax. This equation 17. Now here putting D square equal to minus A square. We have already we have already proved in last slide how we can find D square equal to minus A square. So D square equal to minus A square in denominator. Denominator is this of Pi, particular integral. In denominator of particular integral, we can put D square equal to minus A square. Then D square plus A square here 0. If I am putting here D square plus A square, putting D square equal to minus A square and plus A square, so this is 0. Then here we see that D square plus A square is equal to 0, means denominator is 0. Denominator of particular integral here 0 if we are putting D square equal to minus A square. So here particular integral and this case is not exist. Then we apply other condition. But we know that cos Ax is real part of e to the power Ax. But we know that cos Ax is real part of e to the power Ax because e to the power Ax, this is formula for e to the power Ax. Cos Ax plus I sin Ax. So here real part is cos Ax and imaginary part is sin Ax. Cos Ax is real part and sin Ax is imaginary part because sin Ax is in multiply with I and cos Ax is real number. Sin Ax is imaginary number. Cos Ax is real value. Sin Ax is imaginary value. So real part of e to the power Ix is cos Ax and imaginary part of e to the power Ix is sin Ax. In case 5, every place putting only in denominator of Pi, D square equal to minus A square. Not in numerator, only in denominator we are putting this value, D square equal to minus A square. Then Fd square equal to F minus A square. Putting D square equal to minus A square. But this must be 0. So my problem based on case 5, F minus A square equal to 0 I have given in starting. Case 5, if F minus A square equal to 0. This minus A square putting in place of D square. So F D square equal to F minus A square, this must be 0. If given question Q equal to sin Ax or cos Ax in both function, we apply same procedure to finding Pi. To find Pi, particular integral. Now finding Pi of problem 1 given as follows. So one equation is given is this. This is equation number 4, d square plus a square y sin ax. This is for d form. I am taking this equation. And next equation, d square plus y equal to cos a, d square plus a square y equal to cos ax. This is 5 equation in d form. So now pi equal to, this is formula for pi. Real part of, first of all I am writing here pi. Pi is equal to, I am writing here particular integral here 1 upon d square plus a square into cos ax. I am writing this one. Pi is equal to, this is I am writing, this is step I am already writing in last. Pi is equal to 1 upon d square plus a square into cos ax. This I am already writing here in last result. This one I am writing here. This 17 equation. In 17 equation we have already written here. So this equation 17. This is 17 equation. Okay. So here in place of cos ax, I am writing this. Rp of here cos ax e to the power ix. In place of cos ax, I am writing here e to the power ix, and we are writing here Rp of. If here is sin ax, then I am writing e to the power ix and ip of, imaginary part of. If in our question is sin ax, then I am writing here ip of. If there is cos ax, then I am writing rp of, real part of. So again apply here condition 1. We have discussed when q is exponential function, then we have discussed there what condition we apply when exponential function is given. So here condition of 1 in of pi, putting d equal to ia, e to the power ax. This is e to the power iax. So x axis cancel. So a is ia here. A is ia here. So putting here ia, d equal to ia. Then we get denominator of pi is 0. If we are putting here ia, d equal to ia, d equal to putting ia. So d square equal to I square and a square. So this is minus a square. So minus a square plus a square is 0. So I am writing here d square plus a square. D is ia, putting d equal to ia ka whole square plus a square minus a square plus a square 0. So here we see that this denominator is 0. If we apply condition 1, so this is not exist here. Then we apply condition 2. So here apply condition 2 in 18 equation. This equation 18. In 18 we apply equation next condition 2. What is condition 2? In equation 18, e to the power ix taking to left side of pi and putting d equal to d plus ia. D equal to d plus ia in pi denominator. So here rp of e to the power ix 1 upon d plus ia ka whole square plus a square. So this function taking left side, exponential function taking left side, then there is only one number here, constant. In last, this number taking to left side. So here is 1 only. This e to the power ix, this is exponential function. This function goes to left side of particular integral. In multiply, then there is 1 only. And putting d equal to d plus ia. So our results becomes this. E d plus ia ka square plus a square into 1. This equation number 80. So now expanding this square, whole square, a plus b ka whole square. I am open a plus b ka whole square. So a square plus b square plus 2ab. This formula is applied here. So here is d square plus a square I square a square plus twice 2dia. Do multiply of dia and twice 2dia plus a square. This is 1. 1 is constant function here. 1 is constant function because our function goes to left side here. So Rp of Ei is equal to Rp of e to the power Iax 1 upon d square plus I square a square 2aid a square. This is same equation. So I square is minus 1. I am writing here I square is minus 1. I is imaginary number. So putting the value of I square here. That is minus a square. And 2aid plus a square. So a square is cancel here. This is cancel. So we have next Pi equal to Rp of e to the power Ix into 1 upon d square plus 2aid. This is 1. Here we apply condition 3. Condition 3. Taking lowest power of d, taking common. Means lowest power is 2aid. 2aid. Taking common in denominator of particular integral and making binomial. This is condition 3. If exponential function is there, then we apply 3 conditions. Condition 1, condition 2, condition 3. I have discussed in last lecture in detail. So I am solving separate questions for condition 1, condition 2 and condition 3. So here in this question all conditions are apply here. Condition 1, condition 2, condition 3. So binomial, making binomial here. So 2aid is common here. This term is common. This goes to upon this. And here is 1. So we are writing here 1 plus d upon 2ai. Here 1 upon d square plus 2aid. 1 upon 2aid is common. Here is 1. 1 plus here d square upon 2aid. 1d is cancelled. And taking in numerator minus 1. So I am writing here 2aid is common. 1 plus d upon 2ai into 1. This result in denominator. If we are writing in numerator, then taking minus power inverse. It convert in inverse. Particular integral is Rp of e to the power Iax into 1 upon 2aid 1 plus d upon 2ai whole to the power minus 1. And this is constant function into. So this is binomial. 1 plus x to the power minus 1. This is binomial. So here we writing 1 minus x plus x square minus x cube and plus this up to infinity. So here Rp of e to the power Iax 1 upon 2aid. So here alternating. This sign is plus 1 plus this minus. Then we are taking here alternative sign. So 1 minus d upon 2ai plus d upon 2ai ka whole square and so on. Now this constant function taking inside the bracket. Then d is the derivative with respect to x. So this is the function in right hand side. When this function goes to with derivative, then they differentiate to 1. So here is 1 upon 2aid 1 d square 1. This 2ai ka whole square I square. This is 2ai. So d1 we know that d1 is 0. d1 means differentiation of 1. d over dx of 1. This result is 0. d2 over dx2 of 1. This result is 0. And similarly d cube is 0. So all derivative are vanished. This one and this one. This series goes to up to infinity. So all derivatives are 0. Then we get here only first term we get here. So now next particular integral Rp of e to the power Ix 1 upon 2aid and 1. So 1 upon d here. I am taking here 1 upon d. 1 upon d is just inverse of d. D is differentiation and 1 upon d is integration with respect to x. So here is one function. So here is 1. So this is integration 1 dx. Not adding here constant in integration because we are finding pi. In particular integral there is no constant. Only constant occurs in complementary function. So we are not adding any constant in pi. So here integration 1 dx, integrating 1 with respect to x is x. Rp real part of e to the power iax into 1 upon 2ai into x, not adding constant. I am writing here clearly. In particular integral, if you are integrating, then you are not adding any constant. Okay. So multiply by I. Now in denominator is I. So in denominator I we are removing its conjugate. So I multiply on both sides I. We are removing I here. So multiply in numerator by I and in denominator by I. Multiply by I in numerator and in denominator of pi. In above equation, then we get what will happen when we multiply I? We get here ix. Here is x only. So here we get ix and here is I square. But I square is minus 1. We are showing here I square is minus 1. So pi equal to rp of e to the power ix and minus 2a into ix. Putting value of e to the power ix, we have already written in this. E to the power ix equal to cos ax plus I sin ax. This is complex number. In this complex number is real part and imaginary part. So e to the power ix is cos ax and plus I sin ax. So particular integral is rp of real part of 1 upon minus 2a into ix, and this is the value of e to the power ix, cos ax plus I sin ax. So pi equal to rp of minus 1 upon, multiply by this inside the bracket, minus 1 upon 2a into ix cos ax, and minus 1 upon 2a, here is I into I. This I also multiply by ix, and I square x sin ax. I square is again minus 1. I square putting again minus 1. This is I. So this result is plus minus 1 plus this cancel. So particular integral is rp of 1 upon minus 2a ix cos ax and plus 1 upon 2i 2a x sin ax. Now we know that from equation 70 we are equating real and imaginary part. So particular integral, if we have this equation, so now particular integral 1 upon d square plus a square cos ax. When we are given in our question is cos ax, then rp of this solution. I am starting telling you that we can find the solution of both equations simultaneously of particular integral and also complementary function. Both solution we get simultaneous. Okay. So here if sin x given in our question, pi equal to 1 upon d square plus a square, here is sin ax. So imaginary part, IP means imaginary part, imaginary part. So IP of this total, both are same in this and in this, both solution are same. But in this result, we are taking real part, and in this result, we are taking imaginary part. Then we get solution, particular integral of both equation 3 and 5. After equating real and imaginary part on both sides, we get here. So what we get here? Pi equal to 1 upon d square plus a square cos ax. So what is real part? Real part is this one. There is no I. In this part is no I. In this part is I. So this is imaginary. This is real. So if cos is given, then we are taking this part. So answer is, and sin is given, then we taking this part. Here is I, imaginary. This is imaginary part. Sin is imaginary part and cos is real part. So if in our question is cos, then we are taking real part. If it's sin ax, then that is imaginary part. So we are taking this part is imaginary part. So finally, pi equal to d square cos ax 1 upon 2a x sin ax. This is complete pi. And pi equal to 1 upon d square plus a square sin ax equal to minus 1 upon 2a x sin ax. This is formula. We are using in question for pi. This is formula. This is formula for finding pi in question paper, in question directly using this, this is the derivation of. So now finding complete solution of 3 and 5, complete solution of 3 and 5. So y is equal to complete solution cf plus pi. If equation is this given, d square plus a square y equal to sin ax. So sin का answer of sin in cos. We are remembering this. If in our question given cos, then answer is sin and plus. If in our given question sin, then answer is negative and cos. Sin answer of sin is negative and cos. Sin change cos, cos change sin. Sin answer of sin is negative, answer of cos is positive. So this is the way to remembering these two formula. D square plus a square y equal to sin ax, this is equation 4. And y equal to c1 cos ax plus c2 sin ax, this is cf. And this is pi, this is negative. If sin is given, then we use second formula. So this is 19. Complete solution. And d square plus a square y if cos ax given in our equation, then this is cf and this is pi. Cos means real part. So this is the complete solution. Equation 19 and equation 20 is the complete solution of equation 3 and 5. So here we want to discuss some problem same on these two questions. So I am writing here problem is here d square plus 4 n into y equal to sin ax, sin 2x. This is question same on given problem. How we can find CF and PI. So I am discussing in detail. General equation. This is given equation and d square plus a square n into y is equal to sin ax. This is general problem which we have solved in this lecture. We have find the solution of this. Now what is solution of this? This is question. Here is number. A is number here. Number. A is here 2. Here is 2, here is 4. Here is a square, here is a. So a is here 2. So now finding CF. Number 1. First finding CF. CF of 1. Question 1. So putting Q is 0. Putting Q equal to 0. And removing by Q is 0. Then question 1. D square plus 4 into y equal to 0. This equation 2. 3. 2 is general equation. In our question, 2 is general equation. So this is equation number 3. Now, finding CF for finding an auxiliary form. Auxiliary form of 3. Putting D equal to M. D equal to M. And removing Y. Removing Y from 3. Okay. This is the question. Question 1. This will depend on this differential equation. This is standard equation. I have given proof of this differential equation. So first finding complementary function of 1, putting q equal to 0. If we find out the complementary function, then first q must be 0. If q is given, then we are putting q equal to 0. So our question convert into this 3 equation. Finding an auxiliary form of equation 3, putting d equal to m and y removing, because y is our function. We find out the y. So y is never 0, but its coefficient is 0. So m square plus 4 equal to 0. So m square equal to minus 4. M square equal to minus 1 into 4. M square equal to I square into 4. Because I square equal to minus 1. This value I am putting here. So this is 4I square. 4I square. This is M square. So M square minus 4I square equal to 0. So M का square minus 2I का whole square equal to 0. This is A square minus B square. This equal to A plus B and A minus B. So I am writing here M plus 2I and into M minus 2I equal to 0. If M equal to 2I, M plus 2I, M plus 2I equal to 0, then M equal to minus 2I. This is one root. And M minus 2I equal to 0, then M equal to 2I. This is second root. So M equal to here plus minus 2I and this 0. So M equal to here alpha plus minus I beta. Comparing this one, this result and this result comparing. So alpha is 0 and beta is 2. Then we can find CF. CF equal to C1. I am writing formula here. E to the power alpha x C1 cos beta x, C1 cos beta x plus C2 sin beta x. Okay, putting value of alpha and beta in this formula, then we get complete CF of given question. So our answer is CF is C1 e to the power alpha is 0x and in bracket C1 cos beta 2x plus C2 sin beta sin 2x. This is complete CF. Okay. Now particular integral pi. Pi equal to here 1 upon d square plus 4 into q. Q is given or sin is given. Here sin 2x. So here I am taking sin 2x. Okay. So now I am writing formula here. D square plus a square and sin ax. This formula. Sin ka cos minus. I have proved this formula here. Sin. This formula sin is minus. This formula using here minus x upon 2a minus x upon 2a and into cos ax. This formula using here direct. So our pi is equal to 1 upon 2a. A is 2 here. A is 2 here. So here minus x upon 4 and sin 2x. This is pi. I am direct using this formula. A is putting only A. A is 2. So here is cos ax. Sin means cos ax. Here is cos ax. Cos 2x. So now complete solution. Y equal to complete solution CF plus PI. This is complete solution of one. Complete solution of one question. So here is y is equal to CF C1 cos 2x and plus C2 sin 2x plus PI x upon 4 and cos 2x. So this is complete solution of given question. Similarly, we can solve another problem. D square plus 1 into y is equal to cos x. This is same problem. This is equation 1. Solve. Solve this problem. D square plus 1y equal to cos x. In detail, we can write this problem d2y over dx2 plus y equal to cos x. Here a is 1. So here, first of all, first finding CF. Finding CF of 1, putting q equal to 0. Putting q equal to 0. Then we get d square plus 1y is equal to 0. This equation 2. Now, finding auxiliary form of 2. Then putting d equal to m and removing y. And removing y from 2. Then we get here. So here m square plus 1, this equal to 0. So m square equal to minus 1. Minus 1 is I square. So m square equal to I square. So m equal to formula is plus minus I. So m equal to here 0 plus minus I. So here m equal to alpha plus minus I beta. Alpha is 0 and beta is 1. So here using formula for CF. CF is C e to the power alpha x in bracket C1 cos beta x and plus C2 sin beta x. Putting value of alpha and beta. So e to the power 0x in bracket C1 cos x plus C2 sin x. Sin x here. So this is CF. This is C1 cos x plus C2 sin x. So this is CF here. CF. Now Pi. We find out Pi. Pi equal to 1 upon d square plus a square cos ax. Here is cos given in our question. Cos is given in our question. So our answer is sin. Cos ka plus equal to x upon 2 x upon 2a sin ax. This is Pi. I have proved this formula direct. We can here direct this formula in our question to find particular integral. Only putting value of a. Putting value of a. A is 1 here. So Pi is equal to 1 upon d square plus 1 into cos x. This equal to x upon 2 sin x. This is Pi. Now complete solution of 1. Complete solution of d square plus 1 into y is equal to cos x. So this equal to y is equal to CF plus Pi, particular integral. So CF complementary function, y is equal to C1 cos x and plus C2 sin x and plus x upon 2 is 1 and cos is sin x. So this is complete solution. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.